This section deals with exponential functions, and a very famous example of that is continuous compound interest. Now, the formula for continuous compound interest, that means interest compounded like every second, or every split second, every microsecond, I don't know how you say it, but continuously, is a similar but different than the formula we had for regular compound interest. The formula is A equals P times e to the RT. P is the original principal, R is the regular interest rate, T is the number of years, and A is the final balance. So there you go. Notice there's no number N like we had. Oh, E, by the way, is the number E, 2.718. So Amber invested $1,000 at 10% compounded continuously. How much will she have at the end of 1 year? And also, how much will she have at the end of 2 years? Well, let's figure it out with the formulas. Well, for the first problem, I'm using P as 1,000. R is 10%, as a decimal is 0.1. T is equal to 1, so 0.1 times 1, well, that's just 0.1. And then if you use a calculator, you get 1105.17. So at the end of a year, Amber will have $1,105.17. For 2 years, I just plug in T is equal to 2. Everything else is the same. And I get 1,000 times e to the 0.2, which I didn't. If you just plug this into a calculator, you get 1221. So after 2 years, Amber will have $1,221.40. By the way, notice that in the first year, she makes $105.17, a paltry amount, while in the second year, she makes $116.23, because to go from 1105 to 1221 is a jump of 116. So she made more money in the second year than the first year, but that makes sense, because in the first year, she was making interest, and on the second year, she's making interest on the interest.